Okay, welcome everyone. Can everybody hear me? Okay, yeah. And I just how can I tell if they can hear me on here? Is there a chat function somewhere? We can't check. I can't find the chat here. How would I know if they can hear me? Leanna, do you know how I can tell? Oh, you're right now. Oh, perfect. I'll just wait. Sorry. That's okay. I prefer not to touch anything because then I have to get it back. So.
Just so you're aware, you don't have to wear your mask.
Oh, okay. Well, you know, I'll keep mine on, and then now you can have yours to take off. Okay.
All right, I have the chat open now.
Oh, there we go.
Right.
Okay, that's great. Thanks. I just wanted to make sure because there's nothing worse than watching a Zoom meeting where you can't hear the person talking. So welcome everyone. It's really nice to see this many people in a room. Robin Roots and I were just saying that it's been a while since we've attended in-person talks, and it's really nice to see faculty and students together again. So thank you for those of you who are joining us in the room today, and for those of you who are online, also thanks for joining. It's really nice to have a flexible environment, and hopefully this is how we'll continue going forward. So welcome everyone to the Health Research Seminar Series. This is an ongoing series put on by the HRI, which mostly targets local researchers who are doing research across a real broad range of health research at UNBC. And today we have Dr. Malgorzata, who is a faculty member with the Northern Medical Program in the Division of Medical Sciences at UNBC. So Mal is a colleague of mine, and I asked her for a bio for me to give her an introduction, and she sent me the most colorful, wonderful story about herself that was a little bit too long that I could give today. So I'm going to give you a shortened version, but I think that along the way you're going to understand that Mal has a very colorful personality, and I'm sure that will come out in her talk today. So Mal is a family physician who has a love for clinical practice as well as medical education. She's as a medical educator, she was a master teacher and the co-chair of the physical exam course at the University of Calgary for their undergraduate medical program. She then moved on to Saskatchewan, where she was the program director for the Rural and Regional Family Medicine Residency Program. And since 2016, as I mentioned, she's been an assistant professor with the Northern Medical Program here, where she's balancing research, teaching, and administrative work. So Mal is currently working on her PhD in medical education in embodied cognitive theory, and she hopes to make learning easier and funner for medical trainees. Her energy is fueled by 2 loving puppies, a semi-disgruntled husband, and a daily rock star. So there you go. Okay, thank you again, Mal, for presenting today. And just so you guys know, in case I don't have time at the end, our next seminar is scheduled for Thursday, November 18th. So it's every 3rd Thursday of the month.
You took my notes.
What did I do?
My presentation notes. No, I feel very naked without them. All right, well, thank you, Sarah. Let's see if I can just move this thing somewhere different, perhaps to the bottom. There we go. No, then I'll leave it here. If it interferes with the titles, then I'll move it. So hi, everyone, including those of you who are joining us online. I'll jump right into it. I'm guessing that most of you are here because you want an answer to the following question. So a little bit about disclaimers and biases. I am a PhD candidate. My other bias here is that I do not enjoy physical activity. If you see me walking, as you see in the first picture, it is only so I can get to a destination where I can sit. A little bit of an overview of how this afternoon is going to go. So there will be a couple of housekeeping items, a brief introduction to this idea of legs and brain coming together. Then I will talk about a study that really influenced the beginning of my PhD that I think is just a brilliant study. The next, absolutely nothing, is about my work in the PhD world, and you guys will understand very quickly why that is the title of that particular section. And then we will conclude with just some wrap up of things in Walk the Line. There will be time at the end for questions. If you have some pressing ones throughout the presentation, by all means, let me know. Liana, I'll leave it to you to kind of follow the chat in case there's any questions there. But I want to bring your attention to the experimental part. This is a very interactive presentation. I will not be doing the entire content of this afternoon. So I hope that you guys are ready and willing to participate because you guys will be creating some of the content as well. So in terms of housekeeping, you were asked if possible to bring your phone or your tablet. So if you go on your phone to your browser and go to the website sli.do, sli.do, D-O. It's a polling app. It will not download anything on your phone. No worries about that. It will simply ask you for a session number. The number is 989. There will be no polls. There shouldn't be any polls yet there, but eventually stuff will show up and I'll let you know when it's showing up. The other thing that you should have today, if you can, is a blank piece of paper and a pen or a pencil. If any of you don't have one or your pencil just broke, there's some at the front. Again, I will be providing some data information, potentially some knowledge. We'll see how far we get. But you guys are responsible for the insight, wisdom, and creativity that is involved in this session. So let's start with a brief introduction to this idea of legs and brain coming together. As most things in science, these things don't arise in isolation. And so we are here to kind of provide you, or I am here to provide you a bit of a context as to how this whole idea came about. So it's going to be a slightly grim next slide, I apologize. But some of you may remember around 2010, there were news stories coming out about how sitting is the new smoking, right? And sitting was going to kill all of us. Now, we won't debate whether this is a correct or incorrect statement today. The point is, it came out. And someone, not me, but someone out there, looked at the news stories about this particular topic in the media. And between 2012 and 2016, so a 4-year span, the number of stories on how sitting is the new smoking increased by 12-fold. Now, if you were to graph that and you looked at how many active workstations were being bought at the same time, you would see that the two kind of go up together, maybe not at the same speed, but fairly closely. Now, if some of you are sitting here thinking, what is an active workstation, Mel? Well, an active workstation is a desk at which a worker can stand, walk, or cycle while performing the tasks that they would normally do at a sitting desk. Over here, you have one of my colleagues from Calgary who right around 2012 or so really went into the whole walking desk situation, so much so that he was on the media on a regular basis, probably contributing to that 12-fold increase, right, in news stories. But that's what a workstation or an active workstation looks like. All right, so let me try to not screw this up. I want to go here and I want to see who's in the audience. So I will ask you a question. And this should show up on your phone. Which statement is most representative of your current situation when it comes to active desks?
Does the screen share is paused? I'm so sorry to interrupt.
That's okay. And it doesn't matter whether it's a commercial one or one where you just put a crate on top of a lecture theater desk and you stand behind it. Thank you. The problem is it doesn't then share this screen, I think. Okay. So 54%, 50 only of you, half of you have a desk and are super happy with it. They use it all the time. Oh no, that's not right. You guys tricked me. You are happy sitting at your desk, but you do get up and walk around often. Oh, you switched there. Oh my goodness. Okay, let's see. How many of you own a desk? So those of you who own a desk, who would like to own a desk, also make up a large percentage. I personally would have voted, big surprise here. I like sitting at my desk and I hope this presentation doesn't ruin it for me. All right. Let me stop the polling here. And, oh no. This one, all right. Darn it, these things are so easy on your home computer. And then all right. So if you have or you want to have an active workstation, most likely it's because you think that there might be some health benefits. And there's lots of research around that, and we won't go into there, but there are some benefits. Probably not as many as people think there are, but there are some. However, the question today is, are there actually benefits to our brain? And the reason why people started looking at this is because prior to this whole craze of smoking and sitting and active work desks, there was quite a bit of research being done looking at physical activity of the aerobic type, so cardio type, right? That gets your heart going in the elderly. And there is really good research there that shows that if the more fit an elderly person is, there are some benefits to their brain. And so people were thinking, okay, well, sitting is the new smoking. They're not exactly walking super fast, right? You saw the speed at which my colleague was walking, but at least they're not sitting. So there should be some benefits. And that's how this whole research area of looking at walking and the brain came about. So when I started doing my PhD, I realized that this area falls within the broader category of something called embodied cognition or embodied cognitive theory. At its simplest, because it's a really broad theory, is that there is a link that exists between our brain, our body, and our environment. Now, when I read that, I'm like, okay, whatever that means. And then I found a study that I'll share with you that made absolute sense. So imagine you're opening a jar of pickles. Pickles, people, come on, we want to get those pickles. Open, you have that movement with the hand, right? That's happening. Okay. Now, if you were opening your jar of pickles and you were reading a story that was set in the future, tomorrow, the day after, next year, whatever, in the future, you would open that jar of pickles faster because your hand would be moving faster than if you read the exact same story set in the past. Same story, only difference is the tense of the verb has changed. And yet your hand gets activated by the future and slowed down by the past. There's no reason for that, right? This is a mechanical motion. Why would what I'm reading make a difference? It does. And hence, at its simplest, that is the link that we know exists in some situations between the brain and the body. So I got thinking, what about my medical learners? So if there's an advantage to potentially walking, standing, or cycling while you're working on something, and as a teacher, I would like for my students to just get things faster, easier. As a person who is no longer in the prime of her life, it also would be nice if I could just jump on a treadmill, right, while I'm solving some medical mystery in my clinic, and the ideas would just start sparking in my head. That would be so awesome. So I started looking, and that literature does not exist. So no one has actually looked at the medical community, but not only that, no one has looked in this area at people who have a certain amount of expertise within a domain. So when I started my PhD, most of the studies, nearly all of the studies that were being done in this area were on what I would call the general population, right? So people pulled off the street, our psychology students, right? Kind of first, second year psychology students, they're easy pickings for these kinds of experiments. And the tests that the participants were submitted to were all very non-specific, very general tests. They did not require any in-depth knowledge of anything. So kind of cool, but not really applicable to real life. And so hence, I was wondering if this phenomenon exists, and there's good reasons to believe that there is a connection between the brain and the legs that is amplified by standing, walking, cycling. What happens when you have someone who has an area of expertise that is now trying to learn more within that area? Is there a boundary to this phenomenon that's been shown in the general population? And so that is the gist of my PhD. All right, I'm going to screw up the screen again, Leanna, I'm sorry. We're going to go back to Slido somehow. And we will do question number 2. Do you think that walking on a treadmill will improve some aspect of cognitive performance in medical learners? And we're talking about medical students, residents, even attendings, so full-on physicians. I won't ask you to justify your answers, so feel free to answer whatever your gut tells you. Fair enough. All right, most of you say, yeah, there's probably going to be some aspects of the performance that will be improved. Others are more cautious, right? I know it depends, man. Like when you're trying to trick us what's happening. And then there's those of you who are the social justice warriors in our world, and who are saying, Mal, medical education is already so hard. Why are you torturing these poor souls?
I'm just worried they're gonna fall on the treadmill while they're- That might be from experience.
So that is actually something I have to submit in my ethics, the risk, which has been studied, by the way, the risk of falling on a treadmill. That's for another presentation though. All right, is this working? Okay. Yep.
Share and then share with the news.
I can't do that. I'm on.
Okay. I can just do it.
So when I was reading at the start of my PhD, as we all do, I found this study by Opezzo and Schwartz. And these two people were interested in trying to see how ideas are generated and whether walking can improve them or not. And so their question was, all right, this is where you need your piece of paper and your pen. You will be replicating the experiments that were part of this study. So in this study, Opezzo and Schwartz used two psychological tests. You will be performing both psychological tests today. The answers will be given to you, so don't freak out. Like there is an actual reward at the end of it. First, the two tests were applied with the participants sitting, and then the two tests were repeated with the participants slowly walking on a treadmill. You're asking speed, I hear, yeah, okay. So 1.5 miles per hour. An average 20-some-year-old walks at a speed of about 3 to 4 miles per hour, according to research. So this is like you're dragging your feet in the morning, right? On the treadmill, it's just to get the legs moving. Now we will only do each test once, and it will be a condensed version. And so I would invite those of you who think that you might perform better on the test if you stood, to stand up if you so feel. And the rest of you, well, you can remain seated and see what that does to your scores. I will show you the first test. So you will be given the name of a common object. In this case, the example is a newspaper. And then, because I'm such a nice person, I will tell you how this object is commonly used. So a newspaper is commonly used for reading. Your job after that will be to list as many uses that are different from the common use for that object. So as an example, you could start a fire with a newspaper. You could wrap garbage in it. You could make up a kidnapping note, right? Like the sky's the limit in terms of possibilities. Whatever your brain comes up with, jot it down. Okay. There's only one rule in this test to do well on it, is you have to be specific. So if you say, well, I could use a newspaper if I needed something to fold, not really specific enough. However, you could say, I could use a page out of the newspaper and fold it into a paper airplane. That would be a specific use. Okay. Any questions about how this test should go? You will have a full minute to come up with as many ideas as you can. There will be a timer at the bottom, so you will know how much time you have left. And I will let you know when the test is over. For those of you who are interested, the name of this test is Guilford's, the guy who invented it, alternate uses test. It is a very common psychological test. All right. Papers and pens ready. Your common word is a brick, and it is commonly used for building. What other uses is there for a brick? Time's up. I won't give you the answers right away because we will go straight into experiment number 2. You still need your pen and paper. All right, experiment number 2. You will be given 3 words, and your job is to find the one single word that combines with each of those words. So in the following example, soap, soap opera, hand soap, dish soap. The common word can go either before or after the 3 words, doesn't really matter, but there is only one solution to the combination of 3 words given. All right, let's just do one more example. Cottage Swiss cake. Cheese, excellent, yes. All right, you guys will just do great on this. The twist is you only have 15 seconds per combination of words to come up with the correct word. So no pressure, but a little bit of pressure. For those of you who are bored on Friday nights, compound remote association test is the psychological name of this test. All right, ready? Here we go. You can sit or stand, up to you. Here, ready? Didn't hear huge sighs of relief, so hopefully you guys got the correct words. The 4 words that you were looking for were watch, check, cart, right? Cartwheel, hand cart, shopping cart, and a brain. The percentages are when this test was being developed and was being tested on, again, a general population. It is the percentage of people who managed to get that word correct, could find the common word given 15 seconds to find it. All right, so while some of you are rejoicing and some of you are probably questioning your life choices at this point, let's move on. Perhaps you did better or worse on test number 1. Now, test number 1 is a little bit more complicated in terms of the analysis, but let's go through it. So the first thing you should look at is just how many ideas did you manage to generate for your brick, right? You just count them, there you go. Then you look more closely at your answers. Make sure that they're not vague. Make sure that they're different from the common use. Make sure that they're feasible. So if the common word had, or sorry, the word had been tire, and you wrote that you could wear it as a pinky ring, well, clearly that's not a feasible use and you would eliminate that from the list. And that it's non-repetitive. So if you said that you would use a brick to smash a window to get into someone's home, and then you also wrote that you would smash the doorway to a store to get into the store, it's repetitive. You're still using the brick for the same thing. All right. So you've crossed off some things, you've counted them. Now we're going to check if your ideas are novel. And the way we look at this, and the way Pezzo and Schwartz looked at it, is that they kind of said, okay, well, this person said that they would use a brick to squash an ant. Did any of you have squash an ant as one of the possible uses for the brick? No? So it's now considered an appropriately novel idea. And in the Pezzo and Schwartz world that they created in their research, that was their operational definition of creativity. So it's a little bit hard to figure out what's happening here because there's so many of us and some of you are online. We don't need to switch screens here, but what I will do is I will open the next poll where pick one or two ideas that you have that you think are unique, that no one else in this room would have thought of to do with a brick, and just enter them here. It's going to be a word cloud. And once in a while, glance back and see if someone else wrote something that you also have on your list. And if so, write it again, and then that word becomes bigger. So the big words we know many of you thought about. The smaller ideas we know will be unique. And I'll come back, excellent. I'll come back to this later, hopefully. And hopefully this won't close. Is the poll still open, you guys? Yeah. Okay, excellent. But I'll keep going. All right. So these were the results of the Pezzo and Schwartz study. So let's do one test at a time. Remember, both groups started by sitting. And when they sat and tried to come up with as many ideas as they could for whatever common objects they were given, they generated about 6 ideas. When that same group started walking, they suddenly generated what, around 11 ideas, almost doubled the number of novel, unique ideas that were generated, right? Huge increase. Now, if we look at the second test where you're given 3 words trying to find the one common word, yeah, most of them could find out of the, I'm trying to remember, I think 16 combination of words that were given to them. Most people on average could find 5, 6 of the words. And then when they started walking, well, they decreased a little bit. Statistically significant, but not, super impressive. Okay, so let's talk about the green line, because I think that's the one that, at least for me, impresses me the most. And I'm thinking, wow, this is awesome, right? Like clearly walking or standing or doing something helps the brain. But then I'm thinking, okay, let's play devil's advocate here. When I'm brainstorming, it takes me a while, and then I warm up. And then by the time you ask me, the next question, my brain is ready to go, right? Like it's figured out how it's supposed to react to this test, and off it goes. Well, Pezzo and Schwartz thought the same, that this wasn't proof enough that there was a connection between the brain and the legs when trying to think of creative solutions. And so they did a second experiment. Concentrate on the green line. That is the same situation as experiment number 1. And this is only for that creative test, right? So they gave people some words, asked them to come up with different uses for them while sitting, and then they walked. They generated slightly fewer ideas while sitting, but it was also a different set of words that were given to them, so fair enough. But look, the slope is still very similar, and they almost doubled their ideas again. So they managed to replicate their own experiment. Now let's look at the red line, because if my devil's advocate argument is true, and you kind of get warmed up, right? And you can figure out what, like the next word, you're warmed up, ready to think of ideas, then the red line should be going up. And yet the people who started sitting and remained seated, again, slightly down, not enough to be statistically significant, but still, right? There was no increase there. So it's not a warming up of the brain effect that we're seeing here. They had a third group this time, the blue line. So those guys started by walking. And my, oh my, with no warming up period, look how many unique ideas they generated. And then they had that group sit down. And notice that even after they sit, they still manage to generate as many ideas as the group that was sitting and then walked. What the blue line tells us is that there is a delayed effect on the brain to walking, right? So walking has some kind of effect on the brain, but then when you sit, that effect persists for at least a certain amount of time. So Opezo and Schwartz's study could be summarized thus. If you are trying to think of creative solutions to a problem, you are probably better off standing, walking, cycling, either while you're thinking of these things or a short time after you've done kind of some kind of physical activity. It doesn't have to be exercise, just physical activity. Remember, these guys were walking super slow. On the other hand, if you are looking for a specific solution and there's only going to be one, what we call convergent thinking, you're trying to converge your thoughts, then you are probably better off sitting. All right, oh, this is my reminder to go back. Oh my goodness, to the Slido slide. So many of you have thought of using the brick to build a road. It's a great idea, it's just not very unique, right? So therefore, by the definition of this study, not creative. To weigh down a tarp, slightly fewer of you, but still not a unique idea. And then there's lots of unique ideas. So you guys can see how in a minute, many of you probably managed to generate 5, 6, 7, 8 maybe unique ideas, kind of in line with what the Opezo and Schwartz guys did as well. Great job. Sorry, Leanna, you're getting exercised, but as you've heard, it's good for your creativity. All right. So this brings me to my PhD. And for those of you who may want to leave at this point, because you've had enough, I'll give you the question that I'm studying. Alongside the results thus far in my PhD. So a reminder. All right, that's my PhD in a nutshell. Now, let's dive a little bit deeper into this. So as a reminder, what I'm trying to do is look at medical learners and whether I can use walking as a way to enhance their brains, and or if there is a limit within that group to that particular phenomenon. So as I mentioned, I was really intrigued by this idea of creativity that Pezzo and Schwartz, because I think that we also have this in medicine. And so I postulated, this is a setup, by the way, of the original lab that got taken all over Saskatchewan. I postulated, oh, you can't see that, that there is creativity when we come up with a differential diagnosis. So a differential diagnosis is when a patient presents with a bunch of symptoms and we try to think of all the different possibilities of what could be wrong with them. So I created 4 cases. Each case had 10 signs and symptoms. And I asked people to come up with as many diagnoses as they could. What's happening? All right. I had 18 residents, family medicine, second year, who I consider to be my experts for the purposes of this study, and 18 second year medical students who I consider to be the non-experts. And this is an example of the list of signs and symptoms that they would get, and then they would be given a certain amount of time to come up with what could be wrong with this person. Now notice that there is no age, there is no gender. So we asked them to think broadly, right? What if this was happening in a kid? What if this was happening in a kid who was a female? What if this was happening in an older woman who was a female? What about an older person who was male? So that you could come up with as many diagnoses based on that as you could. Okay. Pen and pencils, please. So I will give you a list of 10 signs and symptoms and 1 minute to think of as many diagnoses as you can. Ready? Yeah. Yeah, I'm just joking. We're not going to do that experiment. So just to show you, we actually did have right and wrong answers. So for example, with this list of signs and symptoms, things like an electrolyte abnormality or an ovarian torsion or a biliary tree obstruction were all acceptable answers. But this combination of signs and symptoms would never be seen in a chlamydia patient or with someone who had an inflammation of the brain like encephalitis or in a kid that had Kawasaki's disease. So people came up with a multitude of ideas, and just like Pezzo and Schwartz, I did a similar filtering system, right? So we counted overall the number of ideas that they had generated. We then looked at whether, like if you thought it was a kidney infection and Sarah also thought it was a kidney infection, well, the kidney infection didn't count for either of us. And then we subjected this list of only unique answers to 3 family physicians coming from very different backgrounds. And we asked them to tell us whether a specific diagnosis was possible. Not likely, just is it even in the realm of possibility using the majority of the symptoms you see there? And we did not define majority, by the way. And so those that were seen by 2 or more of the physicians as being within the realm of possibilities were considered to be appropriately unique. Now, look, the first 2 cases, everyone was sitting, regardless of whether they had been in the sitting or walking condition. This is all sitting, and everyone created the same amount of total number of diagnoses unique and appropriately unique. But really, what I'm looking for is the post-test phase, right? The right side, the colored side of this graph or this table. This is where the sitting guys remained seated, but the walking group now started walking slowly on a treadmill. I'll save you the calculations because I did them and redid them and redid them again. There is no difference between these numbers between the 2 groups. So that kind of sucked. But what sucked even more is that the whole paper that I wrote around this was based on the premise that there is creativity in medicine. And the reason why I feel very comfortable saying that is because much smarter people than me have done the research around this. And they have shown that when we solve a non-creative problem or a creative problem, the same steps occur in our brain. The difference is with the creative problems, those steps don't necessarily occur in the same order, right? The combination of the steps is different. And we kind of skip the evaluation step. So when you're brainstorming and you come up with an idea, your brainstorming dies the moment you say, is this a good idea? Is this possible? Right? That's no longer brainstorming. Brainstorming is coming up with an idea being, yeah, awesome, that's an idea, writing it down and moving on to the next one. So I feel very comfortable in saying that there is creativity in medicine. Now we got reviews, and I do believe in the peer review process, but I tried to summarize what the reviewers thought of my creativity argument. And this was really the only video that I could find. So what this experiment taught me is that there is actually quite a bit of opposition in our medical community in thinking of some of our thinking process as being creative. And one day I will come back to this, hopefully after my PhD. All right, so medical creativity on a treadmill, nope. So then I read and read and read, and then I found that visual recognition is actually one of those areas that is also enhanced when you walk on a treadmill. Well, that's awesome, because we all have skin and stuff happens to our skin, and we visually have to recognize what's happening as physicians to someone's skin. There's an experiment. So notice this time there's a lot more participants. There were 29 second-year family medicine residents. There were second-year medical students. And then there were our poor little psychology students who represented the general population, with medical students being one step above that and residents being, in this case, the experts. So each of these groups of participants got randomized to either sit or walk. No surprise there. That's kind of how my research goes. And then they were shown 20 pictures of different skin conditions, and they had to tell me what the skin condition was. Now, I'm not a monster, contrary to what some of you thought on that first question of why I'm torturing these medical students. And so I gave them 4 conditions that they could learn about before they were shown the 20 slides. So they got to learn about 4 different conditions. And the reason we did that is because, well, we had psychology students there, right? And we don't really expect them to know any skin conditions. So we gave them a chance to learn about some of them before they got tested. So these were the 4 skin conditions that were there. And you'll notice the molluscum contagiosum and the common warts kind of look similar-ish. And that was on purpose because those 2 are often confused by physicians. The other 2 slightly different, but these were the 4 different conditions that they learned about. Okay, this time it's not a joke. We are actually going to be doing this test because just like psychology students, I can teach you stuff. So grab your piece of paper and your pen, and you will have 30 seconds to study a slide on which there is a picture representative of a skin condition. And then there's some brief explanations on the side of things that make that condition what it is, how you would recognize it. Following that, there will be 4 slides of skin pictures. And for your purposes, try to see if you can identify which one is the same as the skin condition you will be learning about. I don't expect you to know the other ones, but at least try to recognize that one. It's a multiple choice question, so all the answers are written. You just have to pick the right one. It's as easy as it comes. There's a 5-second black screen between each picture just to rinse your visual palette. You guys ready? All right. Well, you can't say that I didn't give you great quality pictures. So hopefully some of you have redeemed yourself from the previous test. Here are the answers in case you're interested. The third slide was the common warts. See if you identified it correctly or not. All right. So let me tell you guys a little bit about the results. So as a reminder, this is where we're at, right? Some were walking, some were sitting. All of them had a chance to learn about 4 conditions. Then they looked at 20 pictures. Now, the trick was, and they did not know this, is that within those 20 pictures, 4 of them were the same 4 that were in the conditions that they had learned about. The exact same picture taken, put in there. 16 were new pictures, but all of them were of one of the 4 conditions. Now you'll notice there were 6 possible answers, right? So we did have 2 distractors for those who either were just guessing or so forth, but really there was no memorization, right? You could just look at the list. You didn't have to even know how to pronounce any of the words. You just had to tell us the letter that was the correct answer. Okay, so we wanted to make sure that the testing or the training slides were necessary. So what happened with the training slides is we showed all 4 training slides in a row, but we stopped after each one and asked a participant, have you seen this condition before? And they would say yes or no. And then we would show them the 4 slides, training slides again in a row without stopping that time. So they got 2 chances to see each training slide. And as you see, not surprisingly, the psychology students, remember 4 conditions, so 25% would mean they have seen 1 of those conditions. The psychology students had seen between 0 and 1 of the conditions that we were telling them about, so good thing we taught them about them. Medical students, family medicine residents, they saw somewhere between 3 and 4 of those conditions before. Good stuff. So our experts seem like they should be expert. Oh, wrong way. All right, so then we asked them, we looked at the 4 slides, right? The 4 pictures that they had already seen as part of the training slides within those 20 to see whether they would actually be able to recognize those and identify them correctly. And look at that, our training worked, right? Even the psychology residents were able to remember that they had seen that particular picture before, and they were able to identify what condition it belonged to. Awesome. No difference between sitting and walking though. So now, okay, so for those of you who are in the medical education program, at this point, you may want to close your eyes or leave the room because the next slide is a total massacre. This is the percentage of correctly identified conditions out of those 20. And as you can see, most people were able to identify somewhere between 9 to 11 of them. And that includes the 4, like we were helping them here, the 4 that we knew for sure they were able to correctly identify. So other than this being a bit worrisome for any of us who are patients, I think that the other thing that's a little bit disappointing from my perspective is at least in the psychology students where, you know, the general population, we know for a fact walking increases their ability to recognize things visually. We did not see an effect of the walking. Now, you may be thinking, okay, well, why is that, Mal? I suspect that the main reason why that is because it was a hard test. And when things are too hard, there's a ceiling effect that's created, right? No matter how smart, how much you try, it's just too hard and you're kind of stuck at that level. But I'm a glass half full type of person. And so I'm looking at this and I'm going, yeah, okay, there's no effect. Sure, it was hard. But even the people who were walking did just as well on a hard question as the people who were sitting. And so I choose to look at this and say, walking does actually not impact your ability to solve hard problems. There you go, publication, done. All right, so while the numbers weren't impressive, I will say there actually was a statistically significant difference between the number of slides that residents could identify compared to psychology students. But there was no difference between psychology and med students and family medicine residents. And the other thing is that there is no difference between walking or sitting. So visual recognition, not going to get enhanced this way, but it's not absolutely nothing, right? There is lots of data out there that shows that standing, walking, cycling, just moving a little bit during the day has lots of advantages, physical, mental, emotional, you name it. And so I am saying that perhaps we should be walking a little bit more in medical education because we are not impacting performance, but we might actually be helping with things like burnout and stress and so forth. So it is a happy ending to my PhD. This is the end of study number 2. As you can tell, there was a lot more equipment that got carried all across BC. You will notice there is now a rental van. Sadly, we hit a bear on one of our trips. And so I am here to tell you that while research is always sexy, it is not always glamorous. All right, so some of you may say, okay, well, Mal, great, good for you, you're doing your PhD, so awesome. But what does it mean for me? I still don't know. Should I sit or should I go? Should I use that workstation or not? So let me wrap things up for you because it's complicated. So in 2012, which is like 10 years ago. That was the last time that anyone looked at the entire literature available on sitting, walking, cycling, whatever desks. And what they found is all of these things affect whether the desk is useful or not useful. Your age, your gender, sometimes, the time of day that you use your desk, morning, better than the evening, your fitness level. If you are generally a fit person, you will get more benefits on your brain from using an active desk than if you are not fit. I use the word exercise because that's the one that was used in the literature here, but how fast are you walking or cycling? How much are you shifting while you're standing? Probably one of the biggest difference in whether things will work or not better with an active desk is the type of task that you're doing, and also when you do the task. So if you're doing a cognitive task while, let's say, walking at your workstation, you actually need to wait a little bit and get your muscles warmed up before the benefits hit the brain. If you are walking and then you perform your task after sitting down, then you want to wait about 10 to 15 minutes to experience the height of the benefits that the little bit of exercise or physical activity that you did prior to your task will give you. And there is a newcomer in the corner here. Now there are studies that show that, not included in this meta-analysis, that show that potentially your mood. So when you're telling me, should I sit or should I go? My answer is, well, I don't really know, which I know is not a very satisfying end to a presentation. However, I think that we can look to Johnny Cash because he actually summarized beautifully in song kind of when are your best options for using an active workstation. And for the few social justice warriors out there who are wondering, well, what about you, Mal? Well, I still have one more study left in my PhD. And this time, this is the one, I can feel it. And so I will utilize my 1 minute remaining to say, if you enjoyed doing any of the experiments today, I am looking for volunteers to pilot some of the materials. You will not have to walk. You can sit the whole entire time, but just shoot me an email, and I really do need people to make sure that the materials are well done. And that's it. Time for questions.
Anybody in the audience who has a question, unfortunately those online won't be able to hear it, so would you mind me just kind of paraphrasing before I start?
Make your questions short. Tammy.
Sorry about that. So what is your thought of having cycling desks in schools for kids that have ADHD?
Okay. So of course we start with a tricky question from my so-called colleague who asks about my thoughts of using cycling desks or active workstations, right? For kids who have ADHD in schools. So the easy way out is to say, oh, that's a whole other body of literature that I am not entirely familiar with. But I will say this. Elementary school kids and young adults in their 20s are the ones who cognitively benefit the least. They still benefit, but not as much as compared to older adults, for example, from walking or any kind of active workstation. ADHD is a situation where you get distracted quite easily. And often it can be accompanied by some element of hyperactivity where you just kind of have to move. And so there have been studies, and again, not my area of expertise, but there have been studies out there that have looked at things like a chair, but it's modified. So there's a yoga ball on it, right? So when the kid sits, they can kind of jiggle around their butt and move, but their butt is still in their seat. Because what did our teachers say in elementary school? Butts in seats, right? That was the main thing. So here's a way for them to expand some of that hyperactivity energy and hopefully focus their brain a little bit more. There are schools out there who, especially for math problems, math lessons, have these boards, right? So it's a plank on a little ball, and you put your feet on either side of that plank, and you kind of have to balance on the ball. So you're constantly moving your body, trying to keep it in balance while solving math problems. And those guys have shown, again, not ADHD kids, just any kid. And those have shown that the lessons go faster, the kids understand better. So there's definitely schools out there that are using these kinds of techniques, not just for ADHD kids, which I'm going to guess would help them too, but for any kind of kid, there are certain lessons that could be taught based on that. And because I am so connected with Tammy, I know what her follow-up question will be. And her follow-up question is, should I get like bicycles for my classroom, right? That was, yeah, I knew it. So here's the good news. There's actually studies done in undergraduate students, not medical students, just regular undergraduate students, who could, if they chose to, use a cycling machine during class. And they did perform better on the final exams. They didn't have to cycle every class. There's some, limits there as to how much or how little you had to cycle in order to get the benefit, but it does show some benefit. There was also a really neat study with engineers. See, I'm not the only one torturing students. With engineers who were asked to write their exams, again, math-based, right? Standing up versus sitting down. The guys who were standing up, guys and gals who were standing up, did much better, statistically significantly better than the ones who were sitting. So again, it's an area where it's hard to pinpoint what the magic is because there are so many elements, and we didn't realize when we started researching in this area that so many things make a difference, whether it works or doesn't work. And so if you look at the studies, it's really hard to say, well, this will work. We just can say in this population, under these circumstances, it worked. But then oftentimes when the studies are reproduced in a different population or with slightly different materials, it doesn't work. And most of us right now are trying to figure out what are the common themes that we can identify as always giving us a good result.
I have a question online.
Okay.
Have you explored in what ways your findings might imply formal changes in medical education / curriculum and training?
So I guess the online people can't see the question, but I'll repeat it.
No, it's okay. It went out to all the chat.
Excellent. Okay. No, I have some ideas. So surprised no one has asked me, like, for someone who doesn't like physical activity, why am I doing this research? And so I'll start with that question because I like that one much better. I am doing this research because I was frustrated. I kept attending meetings. For those of you who are in academia, you know that's a common thing, and conferences, and I was teaching. And all these people had back problems that required them to stand up and stand, at the back of the room. And I could tell after a while that their back was feeling much better, but they just would not get their butts in the seat, right? Or that person at the meeting who kept knitting. Like, how can you listen and actually be engaged if you're doing something else? So this whole area of study came out of that. And if you guys ever come to one of our medical school lectures, you will see that people will literally put crates, like milk crates, on the desk, put the laptop on there, and just stand in the lecture hall, typing the whole time while listening to the lecture. And that really annoyed me because get your butt in your seat, right? So my PhD came out of that. People frustrate me, and I wanted to see whether there was actually something there because, well, I know that there isn't, right? Well, I was wrong up here. Anyways, have I explored how this could be applied in the medical education setting? So I think that there's a few places where it could be. To answer the question right away, no, I haven't explored it because do we remember the general idea when we talk about creativity and maybe things being slightly different in medicine? Yeah, the reviewers, the raspberry, yeah. That I worry that that's the reaction I'm going to get when I do come up with this. So I want to make sure I get my ducks in a row before I approach anyone. But I think that there are a few areas in medical education where this would work really well. If you look at our current setup here, for example, you will notice that the students go from a small group to an auditorium that's literally a few steps away, right? They don't get to walk a lot. And we know that even a little bit of walking would actually have long-term advantages for their cognition. The other thing, so maybe giving them a bit of time to go outside, which by the way, walking outside boosts your cognitive performance even more than walking inside. Just a tidbit there. Maybe moving the auditorium so it's somewhere else, right? Like maybe we could use like social sciences auditoriums or something. I don't know. The other thing is we do have these classes called CBL where they have to basically come up with, a whole bunch of differential diagnoses, generate a lot of ideas about a patient, and they're all done sitting down. And if walking, standing actually boosts creativity, or at least doesn't impact it, why aren't we doing those classes that truly are asking us to generate a multitude of ideas with at least part of it standing up or walking around the room? Who knows? I actually often will remove desks from my small room class, and we will be walking around and doing things on the board, standing up for the majority of the session. I think that those yoga ball chairs, why don't we have that in some of our auditoriums, right? So I think that there are ways, especially in the first 2 years of undergrad in medical school, to use some of these ideas to, if not improve brain cognition, at least relieve some of the stress and improve some of the physical, mental, and emotional areas. In the hospital, it's a little bit harder, but one of the studies that I will do as soon as I no longer have to do what my PhD committee wants me to do is I plan to put radiologists on treadmills. So I don't know if you guys know, but radiologists, they sit in this dark room all day, right? Lights turned off, looking at a computer screen, picture after picture, and dictating what they see on the picture. Well, you don't have to be sitting to do that. You could be walking. And I'll see if those radiologists are happier, perhaps dictate better notes, who knows? I think that there's something that could be changed there.
That might answer the follow-up question, which was, what are some next steps and follow-up research work?
Right, so step number 1, finish this darn PhD. For any of you who have done a PhD or a master's, you will sympathize with the frustration here. And after that, yeah, I think that after that, I'll keep going because this idea of sitting being the new smoking, I don't know, but there are definite advantages to getting up more often than we do. And we now know that it doesn't have to be hard exercise that we do. Any kind of movement that we do during the day is already beneficial to our health.
So another online question was, should we be asking for mathematical classrooms with standing tables?
Honestly, I would happy to send that one piece of research with our engineers to that person who's asking. If they contact me, here's my email address. Volunteers, here's my email address as well. I actually, honestly, would say yes, with the option that someone can sit when they want to sit. Because this is only beneficial if you're not tired, right? So if you stayed up all night drinking, and then you come to engineering class, I have an engineering background, so I feel very comfortable saying that it is not a stereotype. You might be too tired at the 8 a.m. calculus class to remain standing. Or perhaps it might help you, who knows? But I actually think that giving the option would be beneficial for a variety of reasons, even if not necessarily cognitive, although the science there is pretty solid. There's a question at the back.
Hi there, I can you hear me okay?
Yes.
Yeah, so my question is about the mood dynamic that was not the main focus of the work, and some of the elements about lag that you mentioned. So that if there is a recognition of a positive mood association, and you were getting indications that the walking had increased cognition, but if you were also testing mood, just how you might think about that dynamic. It's really mood as a confounding variable, it's something that's sort of factoring in, and because you mentioned the lag thing several times, I'm just wondering about how you might frame that interaction.
Right, so it's a brand new area of research, so there's not a lot. Oh, sorry, I have to repeat the question.
Oh, sorry.
People are not following the rules here. All right, to shorten the question, kind of the mood interplay here, as well as, you know, I often talked about that there's a lag, right? So once you walk a little bit, there is some remnants of improvement in brain function in some instances for a little bit after that's done. And so how does all of that kind of work together? Okay, so mood is a brand new kind of area of research. There's not a lot done on there, but the basic idea is if you're already in a good mood and you're walking, standing, cycling, you will get benefits, but not as much as if you are in a bad mood. Because again, we think that there are the brain emotional benefits of physical movement that can occur. But again, really little bit research in this area. In terms of lag, I'm not sure how to combine that with the mood. It's just something that happens. The lag, it has been shown numerous times, right? And that's how we know that you have to wait about 10 to 15 minutes to reach the peak of what you will get after you sit. Hard to tell how that hasn't been studied in combination with the mood, right? And this is where the issue becomes. There's so many of these combinations of factors together that I can answer one at a time. But when you ask me for combinations, there's often very little data, or data that has been shown in one instance, but not in another, which really doesn't tell us much. But I will say, if you have students who want to volunteer, my next study may or may not be in this area.
Maybe I'll just make a comment because I just read a paper before I came here, partly because of your talk, and I was just sort of wondering what was known about mechanisms for physical activity and effects on cognition. And there just has recently been a really biomedical, so not a human study, but looking at the impact of a hormone that is produced with exercise from skeletal muscle that works at the level of the hypothalamus, and they've shown changes in cognition, more in models of aging and Alzheimer's, but really interesting work, and it was just a feature last month. So
all right, to summarize what Sarah said, which is highly technical, she just read a paper that talked about a molecule being produced that affected a part in the brain and improved cognition in mostly the elderly population. And yeah, in terms of mechanisms, why is there this relationship between legs and brain? different people have tried to explain it in different ways. And I don't think at this point there is yet an agreement on the specific mechanism. And so I would postulate that there are probably several mechanisms. Because remember, if you're fitter, then the desks work better for you. And so one of the things that they did is blood work. See, there are people who are more cruel than me who did blood work on their participants and showed that people who are fitter have certain molecules in their body in higher quantities that then get activated faster, better, harder, whatever, when they start using a desk, that the less fit people, while they still have those molecules because they're in smaller numbers and not as active, can just not activate. So there's probably very much some biochemical mechanisms at play here as well. Oh my goodness. Taru?
Mine is a very short comment, follow-up. I think there is also this interesting dynamic about mediation. There's a lot of mediators, so there's some studies that have shown academic performance being enhanced in primary school kids when they reach substitute. But there's a lot of, as you rightly say, factors that can either mediate the relationship between the activity performance, because there's some studies that show that, contrary to where you're physically fit, this helps more. There's some studies that show that if you are more sedentary, you get quicker and more benefits, but doesn't. So it plateaus at some point. So there, I think what I'm trying to say is, this work has so much potential for this. There's so much mediation factors that to get to it takes a while. There are what mechanisms.
So for our friends online, our physical therapy colleague here basically confirmed that I was right in, I get to summarize, I get to make the summary. Basically confirmed that I was right in saying that there are a lot of mediators, and he gave the opposite example, what I have been giving you guys, and it's that sometimes the more sedentary you are, the more benefits you may get in some circumstances based on certain modifiers. So yeah, I definitely will not run out of study material here for a while, at least. Yeah.
I'm just curious if you think there's like a muscle group differentiation. So like walking, cycling, standing is very like quad-based, hamstring-based, which are pretty big muscle groups and demand quite a bit of oxygen. So I'm just curious if you think that there would be a difference, like say if you're doing like one of those hand cycles, just because like when you're doing complex tasks, obviously you lose oxygen. If you're using larger muscle groups, like you're taking some of the demands from the quickly. So do you think there would be a difference if exercise was focusing on different muscle groups?
Yeah, so one of the questions that I still didn't answer for myself, remember I was frustrated with the knitters in the meetings. I would be interested in doing a study with that. Is it any movement of any body part? I haven't seen the studies on that. So far, they've been using kind of the big muscle groups, you're right. And some people have been looking at VO2 max, so the consumption of oxygen by muscles while all of this is happening. And this is why, we recommend walking slowly or cycling slowly. It's to minimize that. You don't want huge consumption of oxygen occurring. You also don't want muscle fatigue. And so by using some of our bigger muscles, they take longer to fatigue. So in my experiments, students sometimes walk up to half an hour on the treadmill and they have no problem. Even the ones who say, oh God, I'm not fit, I'd never go to the gym. It's never been an issue. And their brain functions, well, it doesn't function better, but it doesn't function any worse than the people who are sitting. Oh, I didn't answer. Yeah, the summary to that question was, oh shoot. O2 utilization of muscles means that oxygen isn't going to the brain and isn't being utilized or available to the brain to utilize while solving complex tasks or cognitive tasks. And so is it that you have to use like the big muscles of the legs that you use in walking, cycling, standing, or could you use perhaps some smaller muscles as well? So if you put that in front of my answer, it will all make sense. Last chance. After that, you have to track me down on email. Is that a question?
Thank you for your time.
Okay.
So, yeah, thank you so much, Val. That was really interesting talk, and thanks for the participation. So I actually really appreciate coming today and getting to be part of your talk with everyone in the room. And I realized that my answers to the questions were very average. Anyway, I just want to take this opportunity to thank Val. So please bring me in.
STEM class, let's take 10 minutes and then we'll meet over in our regular. Go for a walk. Yes, go for a walk.